So I'm going to make the title of this video a little bit kind of gotcha. So I want to dive directly into it and directly into my hypothesis within this, which is that LLM models in and of themselves have their own unique sense. And they have the unique sense of pattern recognition. And so, first of all, let's define what a sense is. A sense is a faculty by which the body perceives an external stimulus, one of the faculties of sight, smell, hearing, taste, and touch. These are the senses that are within humans. But there's other senses that exist with external from humans, right? These aren't the only senses that exist. A key example would be ants. Ants utilize pheromones, which is tied to smell, but it could be argued that pheromone usage is different than smell, right? It's a different category in and of itself. And similarly, pattern recognition would be a different category than sight. Pattern recognition could be what pheromones would be to smell. I can see it like in that same category, right? And then so within this, I think the next thing to dive into is how exactly can we equate what an LLM model does with regards towards data learning and processing to this external sense, right? So this external stimulus is what it has to qualify as. And then so to me, the simplest way to do this is to look at this mathematical equation here that we're looking at here, which is the Q learning algorithm, right? And then so this is the Q learning algorithm utilized for reinforcement learning. And then so what this does is very straightforward. This algorithm essentially creates an environment and a stimulus out of anything. That's what the algorithm is, right? The algorithm is Q is your environment. So the Q values, here's the state of your environment. And then based off of that, there's R's in your environment, which are reward functions. And then your job is to navigate your environment and then figure out what actions that you take that increase your rewards and then do those, figure out what actions you take that decrease your rewards, don't do those, and then find out which actions are neutral, and then do those if you're wanting to explore or needing to explore your environment. And then when we put these things together within machine learning, it comes out very straightforward, right? Like, let me show you an example here. If I go and I run qbert.py, just a really simple example of reinforcement learning, right? And then so like what we're doing in this instance is this algorithm that is just born now when I create it and I generate it. It doesn't know anything about what is going on, right? It's all of a sudden plopped into this world of qbert, and then all of a sudden it's getting rewards for taking certain actions. It gets rewards every single time that it's hitting and turning the blue blocks into yellow blocks. It doesn't know that it's turning blue blocks into yellow blocks. It just knows that it's getting rewarded, right? And that's all it does. But so with that, that's operating like pheromones. It's recognizing the patterns within its environment and going through and learning off of that, right? And then we can change this game. Like the game can be anything. It can be, let's say, I'll use Gemini Palm. It could be Breakout. It could be Pong. It could be Qbert, right? It doesn't matter what the environment is. And then in this instance, it's the same exact thing, right? This algorithm is just born. And then we're saying, hey, go through. And then now you're receiving positive rewards every single time that the paddle hits the ball. And then you're receiving negative rewards every single time that orange scores a point. And then so it's going based off of this information and then processing that information about its environment and then going through and learning about its environment in this instance, right? And then so tying this together and tying all of this together, let me go ahead and stop this execution real quick. What exactly and how exactly does this tie directly and specifically into LLM models? And then so to me, we come to this, right? And then this is essentially a visualization of how LLM models look at and view concepts. And then there's a few things and then a few patterns that are very important to note and tease out of this. So very straightforward. All I'm doing in this instance is I'm running code to remove and then to map and calculate the embeddings of a BERT model in this instance, and then I'm visualizing that. And then just to note, one note within this, like these visualizations aren't 100% accurate because of the fact that I'm running this in Python, right? Like what would be better would be to run this flat out in like Prolog or R or like something along those lines as opposed to Python, but it's just for demonstration purposes and for this video and for making this as easy as possible. I'm running this in Python, which gives us close enough approximations to what we would need to look at in this particular instance, right? But so in this instance, we have our keywords, which in this instance are, and our starting words are man, woman, king, and queen. Then I also have king minus man plus woman, which equals queen in the model's instance, right? And then so queen is here. And so this is what our queen is here. So what we're doing in this instance is mapping out and visualizing what exactly the model is looking at and how exactly it's visualizing these concepts within its neural networks, right? And the major thing to highlight here is that if we look at the shape of this, it's a quadrilateral. And then if we like essentially like a rectangle with unequal sides, four sides, right? A four-sided object. And then if we let's look at another example, right? Because maybe it's the quadrilateral could be just a coincidence. So I'll take another example here. And then let's run this guy, and we'll get a small error with it, which is fine. But then again, we have another quadrilateral, right? And then so we've got a little bit of a bend there, but still the same concept, right? Same object, like this, it's a quadrilateral. And then let's look at this one here. Sorry, there we go. Let me fix this error here. Perfect. And so same thing, like quadrilateral shape. And then so just noting off the top, the model, like the LLM model doesn't recognize that it's putting this data into this shape, right? Like it doesn't, it's not doing this consciously. It's doing this like pheromones, like an ant would, right? Like it's just following the instinctual patterns of this. And then so you'll notice that the shape of it is quadrilateral, and then also too there's always it's a mirrored. So if we look at like swim and swimming, and then we have run minus running plus swimming, they're on the opposite sides of each other, right? And that's the case for every single one of these that I've demonstrated and showcasing that as well, right? And then that's why and how it shapes out a quadrilateral every time. But so it relates these concepts together as fractal quadrilaterals, right? Like so, then it's all fractalized, fractal within each other, right? It makes sense. Like so, like these quadrilateral shapes can all fit together into a grid if you have enough, like a bunch of them, right? And then that's exactly what ends up happening with all of these dimensional shapes within this. But so coming back to the hypothesis and the concept within this particular video, which is that this is a sense, right? And then so coming back to senses, most people think of senses as making sense of our environment, that we utilize our senses to make sense of our environment and what is around us. I hypothesize that it's the opposite. It's the exact opposite. Our senses construct our environment. What we perceive as our environment is 1,000,000% dictated by our senses. My back is hurting right now, right? I have back pain that influences and is my world because it's within my senses. And then so I recognize that, I talk about it right now within this video, and it becomes a part of my world, right? It's dictating my world, not telling me what's going on within my world. It's literally dictating it. Same thing as like if I went into a smelly room, right? Like I would be overwhelmed by the smell in the room, and that would consume my world, and then my senses would be constructing my entire world within that instance. Another example, like a really common example and a key example that I think of, is your nose is right in front of your face, right? And your nose is right in front of your face in such a way that it should impede 90% of your visual and of what you do. Like you look at visually, your nose should be there, but your nose isn't there because your eyes account for the fact that your nose is directly in front of your face, and then it gives you a reconstruction of your environment. So you're looking at your environment at all times, 100% of the time, is not your actual environment, right? There's reconstruction going on within your eyes 100% of the time. So you're looking at an image that is 97% maybe your actual environment. And then there's also other factors that play there, right? Like I have half of the visual cones that a female would within my eyes. So that dictates again how my eyes construct my environment. I see my environment and construct my environment literally differently, literally with half the colors. And then that influences my world perceptions, right? And then so going in and then correlating these same things back to an LLM model, the point is that like all of these things, all of our senses and how we utilize our senses is exactly how an LLM model utilizes data and applies its senses to the data. That is what's going on here, right? It's the model's senses, it's sensing the data, sensing the patterns within the data, and then constructing its environment and its world based off of the data. And then it constructs it every single time in geometric shapes, like geometric shapes that we can look at here and that we can reconstruct over and over and over and over again. The same shapes, the same patterns, right? And so within that, like it's not coincidental. It'd be, to a human, how exactly do you represent your world? I represent my world based off of physics and the dynamics involved within that. And you can't tell me any different than that. I know if I jump off of the roof of my house, it's going to hurt. And I know that based off of physics. Whereas an LLM model, they'll say, no, bro, I base the entire world off of geometry. Like geometry is the world, and it's the entire universe. You can construct the entire universe in geometry and utilizing geometric concepts, and then just breaking everything down into these geometric concepts, and then breaking them down into geometric shapes that you can then fractalize and then conceptualize within your brain, and boom, there you go. And that's the world, and that's how I view the world. And both perceptions are accurate, right? But it's the shape, it's the senses that are constructing that world. And then so in this instance, the LLM model is utilizing its senses to construct this world. Highlighting and noting that this is a completely separate argument from AI intelligence, right? Is there intelligence going on here? That's a completely separate argument. Is there intelligence going on within when an ant uses pheromones? If yes, then you fall on one side of this argument. If no, then you fall on another. And then so I don't want to get into the intelligence argument deeper than that. This is a totally separate and unique argument from that. I'm just arguing that within this, how LLM models work, how they operate, and their sense of pattern recognition brings it to a superhuman point, and to a point where their pattern recognition is literally meets the definition of a sense. It's LLM models have this sense of pattern recognition, just like humans have the sense of sight, smell, hearing, taste, and touch, and an ant has the sense of pheromones. And so if you like this type of content, please like and subscribe. Thank you very much.